G'day everyone, so in this video we're looking at instantaneous rates of change. So here we've got a question, draw the graph y is equal to the square root of 16 minus x squared in between -4 and 4 on the x-axis. Okay, so I've actually done this here on the right on my CAS. So drawn that up on what it looks like, and use an appropriate technique to find an estimate of an instantaneous rate of change of y respect to x at these points. Okay, so just remember, instantaneous rates of change, this is the rate of change happening at a point. So with this, we'll first look at a, and I'll do this in black here. So when x is equal to 0, so this is just the gradient of that point when x is equal to 0. So this here will look something like this. So hopefully you can tell the instantaneous rate of change of this one is, we're looking at the gradient, and gradient of a horizontal line is equal to 0. So we're just going to do this one 0, and we're just going to say by observation. Okay, you can see that that's a turning point there at the top there, where it goes from a positive gradient to a negative gradient. So this is where we have our gradient of 0. Alright, we're going to look at another 2 points here. So first, when x is equal to 2, and I'm going to do this in yellow, just on our graph here. So x is equal to 2 is here. So we want to work out the gradient of the graph at this point. So this will be something like this. Alright, and then we'll do when x is equal to 3, which is the next notch there. And this is going to be in red, and this is going to look pink, sorry. It's going to look something like that. Yet again, it's not perfect. But we can see, hopefully we can see that these are both going to be negative gradients, because they're going down from left to right. So they're going down, that means they're going to be negative, and this one is going to be more negative. So we've got a little bit of information just from observation there. But what we can actually use is this formula that I've put here already. Okay, so with this, we can actually just use this as an estimate, is just working out our average rate of change, but we look at it over a very, very small gap. So if we use h, such as a very small number like 0.01, okay, this works over a very small gap, so we can actually solve an average rate of change at a point. Okay, so it looks at this over a graph, a point, and you'll need your CAS for this unless you're really keen on doing it by hand. So we'll go into B here and how we could do this. So here we've got, if we use a very small point such as 0.01, you could use 0.1 or 0.001. The smaller the point is, or smaller h value, the more accurate it will be for instantaneous rates of change. Okay, but this is an estimate, so yet again I'm using 0.01 as our h, so I'm going to use the f. So we're going to put 2.01, so substitute 2.01 for x in our function, minus the f of 2. All of this is going to be over 2.01 minus 2. So here, it's equal to f of, oh, that's not a very good 2.01. Minus the f of 2 over 0.01. So you can see it's over a really small gap here. So this gives us essentially a very good estimate for instantaneous rates of change. So here we've got negative 0.576. So we can say this is a round, or an estimate is equal to negative 0.6. Okay, so you can define fx in your CAS and put this into your CAS, and you'll get an answer. So for part C, and I'll do that in the colour I did it for when we're looking at 3. we're just going to do the same but with the value 3. So f of 3.01 minus the f of 3 all over 3.01 minus 3. Okay, you'll put this into your CAS. I'm not going to show the second step here, or you could work them out individually. Yet again, if you define fx in your CAS, it's pretty quick to do. Alright, then we have negative 1.138 is your answer here. Okay, and then we can say this is approximately equal to, just remember that's what this equal sign with the squiggly bit on the top is, approximately equal to negative 1.1. Okay, so this is how you actually work out approximate instantaneous rates of change. Okay, you're essentially working average rate of change over a very, very small gap around that point there. Okay, so it's the same formula there, and just make sure that you first check out by observation what's going on with your graph. Is it going to be a negative or positive gradient? How negative or positive will it be? So from this, we saw our first one was going to be 0 because it was at a turning point. Okay, and it made a horizontal line with the tangent. So that one made it 0, and then we knew that our third one was going to be more negative than our second one, and our answers followed that. So that's a good way to check if you're doing it right and make sure that you're doing the right thing when you are completing these. Okay, so good luck with working out instantaneous rates of change.